Hello. Myself Tyarajan. I am here with you in order to discuss L6 system call. Past video, past lecture, I discussed about create system call, how we can use a create system call, what is the syntax, and then what parameters are going to be passed for create system call. With example we discussed about that. Right. Today we are going to discuss about the L6 system call. So the L6 system call takes header files #include this is types.h #include unistd.h. Here the syntax for LSIC is LSIC. There are three parameters are passed. One is a file descriptor, offset, and whence. So we'll see about what is the meaning for whence. There is a file descriptor. Already file is opened. When a file is opened, the open file returns some file descriptor, integer value. So it is taking a file descriptor which is already open, and then offset value. Here we are trying to reposition the current file descriptor. So we are trying to reposition the current file descriptor with respect to offset. Right. So here one thing you try to remember, LSIC is a function used for repositioning the offset of open file associated with the file descriptor to the argument offset with respect to whence. Right. Here the LSIC function reposition the offset, reposition the offset of the open file associated with file descriptor. Alright. So according to the whence, whatever may be the offset value, based on that it will reposition from the current from the original position to some other place. Alright. Here from what place means seek underscore set, seek underscore current, seek underscore end. Right. These are whences from what place we need to position the file descriptor from the current position means seek underscore set, seek underscore current, seek underscore end. Seek underscore set meaning is the offset is set to offset byte. Seek underscore current meaning is the offset is set to its current location plus offset bytes. Seek underscore end meaning is the offset is set to the size of the file plus offset bytes. We'll see with an example. So all of this. Coming to the whence. Here previously means we got a new codes for whence. Previously we have some of the old codes are there. 0 meaning is seek underscore set, 1 meaning is seek underscore current, 2 meaning is seek underscore end. Right. So all the right side column is a new macros for whence. The left side values are old macros for whence. Alright. So here I try to understand the LSIC function is responsible for repositioning the offset of the open file which is associated with the file descriptor to the offset with respect to whence. Alright. So it will try to jump to another byte in a file. Alright. So here take for example move to byte, move to the byte 16. The syntax here is new position equal to LSIC. So there is a file descriptor, currently it is pointing to some location. So I am trying to move to the byte 16, and then it will be your it will be your current. Alright, it will be your current position. Alright, we are setting the current position. Right. So next example, move forward 4 bytes. All right. So here the syntax new position equal to lseek followed with the file descriptor comma 4 lseek current. Right. I'm trying to move forward 4 bytes from the current position. Right. It will be your the new current. Right. Seek underscore current. So move to 8 bytes from the end. Right. So move from 8. Currently original your pointer will be at some position. We are trying to move 8 bytes from the end, means 8 bytes backward, right? So here the new position is equal to lseek file descriptor -8 seek underscore n. We'll see one by one with an example diagram. Here you can see the lseek fd comma 10 6 set, right? So the meaning is we are trying to move 10 bytes to the next, right? We will set it will be your current position, right? We are setting the current position for your file descriptor from the original position. The original position is a 0. File descriptor is pointing to the position 0. So here I used lseek fd10. I'm trying to move this file descriptor to the 10 bytes from the original position, and then I'm setting the 6 set. So my new position will be a 10, right? So this is a meaning for this lseek, right? So another example, seek current, right? So lseek fd comma -5 seek current, right? Previously the original position for file descriptor is 10, and then I'm moving backward 5 positions, right? Moving backward to 5 position, and then it will be your current position, right? So your fifth one will be the current position, right? So here original position is 10, -5 indicates a 5 bytes backward direction. So I will get to the position 5. So and then seek current position will be 5, right? So that is the meaning for that. Another example, seek current is 3. lseek fd comma 3 comma seek current, right? So current original position is 5, and then my offset value is 3. I'm trying to move 3 bytes from the original position, and then it will be your seek current, right? Seek current will be the 8th position, right? Previously the original position is 5, so I'm trying to move 3 bytes from 5 means 8, right? So the 8 will be seek current, right? So 8 will be your new position, right? So like this we are going to set, right? So we are going to set position of your file descriptor. So you try to remember lseek function repositions the offset of open file descriptor associated with a file descriptor, open file descriptor to the argument offset according to the ones, right? So and then coming to the another topic, change owner and change mode. There are some functions are there for change ownership and change mode. Change owner, so we create a file, we are the user will be your file owner. You can change the ownership of a file, all right? So here for ownership there are some system calls are there, ch1 fch1 lch1, changing the file ownership, changing the owner or mode of file or operation on the inode, right? So here changing the owner, so owner permission, change mode, change file permission, changing the file permission. Here for this we use functions like ch1 and chmode. So the ch1, the syntax for ch1 is ch1. There are 3 parameters are passed. One is a path name, owner, and the group, right? For chmode, there are 2 parameters are passed. One is a path name, another one is mode. So here the ch1 path name is whatever may be the file path, right? Whatever may be the file name, I need to change the ownership, right? The file name need to be mentioned. So file name can be mentioned in terms of relative path. The file name can be mentioned in terms of absolute path name, right? So and then what is the owner name, and then what is the group name. So we need to mention in order to change the ownership. So coming to the chmod, changing the file permission. So I need to mention to which file I need to change the file permission, right? The file name need to be mentioned here. At the same time, what mode to be applied on this file, right? What permissions need to be modified, that permission need to be mentioned, that mode need to be mentioned, right? So the C syntax for chmod, fchmod is looking like this. Int chmod constant character star path name, and so path name is a character type. So and then mode, so mode underscore t is a data type for mode. Fch mode, changing the mode based on the file descriptor. Here I am passing an input, a file descriptor, and then mode, the data type for mode is a mode underscore t, right? So these are the two syntax you need to keep in mind. Changing file permission with respect to file name, changing the file permission with respect to file descriptor, fch mode. Here I have a syntax for ch1, int ch integer type ch1, const character path name. So here we need to mention to which file ownership need to be modified. So and then owner name. So what is the uid of a owner? So and then group name. What is the gid of a group? Right? gid underscore t is a data type. uid underscore t is a data type for having a owner id. Group id we need to pass as an argument for ch1 system call, right? So at the same time ch1 can use based on file descriptor. We call it as a fch1 call. So fch1 call uses again the same three parameters, but instead of a file name, so it uses a file descriptor. File descriptor, already file descriptor is referred with the help of a open, right? So file descriptor followed with owner id need to be here, group id, right? So lch1 uses again the three parameters, so path name, and then owner, and then a group name. So these are the three syntaxes you need to keep in mind in order to change the ownership. You try to remember change the ownership of a file which is specified by the path name. So ownership, changing the ownership with respect to path name. And then fch1 changes the ownership of a file with respect to file descriptor. So with respect to open file descriptor. So already the file is opened, right? So with respect to open file descriptor, we are trying to change the file permission, right? So already I covered this. The same here, one thing, to change the owner of a file, the kernel converts the file name to a inode using algorithm. We call it as namei, right? So here one thing you need to keep in mind, the namei is an algorithm in order to convert a file name into an inode, right? So using algorithm we call it as namei. So most of the case these algorithms can be studied when you are discussing about the core operating system. When you discuss about internals, Unix internals, so there you can understand, there you are going to study about the naming algorithm, right? So change owner command, changing the ownership of a file or a directory. So try to take an example. So here ls minus l, so we get a long list of a file or a directory which is present in your current directory. So we have a syntax ch1 space ab space file name, right? So ab is a username, and then for a file name we call it as a file.txt, alright? So ch1 abe file.txt, right? So here take for example ls minus l, I can see the